So we're going to use this situation to recap yesterday. I purchased apples and oranges from the grocery store for $18. Apples are $2 per pound and oranges are $3 per pound. My bag weighed 7 pounds total. How many pounds of apples did I purchase? How many pounds of oranges did I purchase? If we want, whether we're creating a system or we're just trying to solve an equation, what do we need to begin with here? We focused a lot yesterday on where we begin. What do we need to know right in the beginning?
What they know.
Okay, we can start with information that we know for certain. Okay, what information do we know?
That the oranges were $18.
Oranges were 18?
Both of them were 18.
Okay, so we spent $18 total. Okay, what else do we know for certain?
Apples are $2 per pound.
Apples are $2 per pound.
And oranges are $3 per pound.
And oranges are $3 per pound. What else do we know?
Oh, I hate that.
Bag weighs 7 pounds.
And my bag weighed 7 pounds. Now that we have identified what information we're given, what must we identify next?
Equations. Oh, the unknown.
Our unknown. We need to figure out what am I even trying to find? Right? What do I need to figure out here?
How many pounds of apples is it?
So we're trying to find the pounds of apples and what else?
Oranges.
The pounds of oranges. How do we want to identify these two unknowns?
A plus B equals 7 pounds.
We need variables first. What variables do we want to use?
A for apple.
A for apples, okay.
O for oranges.
We can use O for oranges. The O is going to look a little weird in some of the equations. Just make sure when you write it, it doesn't look like a 0. So now as we are looking at this system, what we need to think about are the equations that we're going to write to represent the system. We need to figure out topics. There's something in here. There's some information floating around in this problem, and we want to write an equation based on each one. What are the big things that we're given here? What is this problem talking about? Because we need 2 equations. One of them will relate to something, and one of them will relate to something else.
The bag.
What about the bag?
It was total 18 pounds.
Pounds?
I mean, no, 7 pounds. Oh my god.
Well, one of our equations represent pounds.
Yes.
Yeah. What would the other, based on the information that's given, if one of the equations represents the pounds, what would the other equation represent?
The cost.
The cost, absolutely. Thank you. The other one would represent the cost. Okay, the amount of money spent. And if you look at the problem there, and you can see those, I don't want to call them themes, but I know in ELA you talk about themes. If you're looking at this entire problem, you're seeing a lot of stuff regarding cost, and then you're seeing stuff specifically regarding the weight or the pounds. So those are the 2 big ideas in the problem. You can generate your equations based on them. Now, going back and pulling out our information, what equation could we create? What equation represents our pounds?
A plus O equals 7.
Can someone explain that equation in a sentence? What about the apples and oranges? The pounds of apples plus the pounds of oranges equals 7, right? We know that it's a total of 7 pounds. How about the cost? What equation can we come up with for the cost? Go ahead.
2A plus 3O equals 18.
Now, if you have a hard time identifying what to put where, notice that we're talking about $2 per pound to 18, and then we're dealing only with money here. So that might help you to organize your thoughts into an equation. What does the 2A represent? 2A represents what?
The $2 for each.
Is the term 2A just telling us it's $2 per apple?
No. $2 per pound. 1 apple.
1 apple is $2. So what would the term 2A represent? The total for all apples, because I don't know how many. What if we bought 5 pounds of apples? That wouldn't be a 2, it'd be a 10. Okay? And how about the 3O? If 2A is the total cost of apples, 3O is the total cost of oranges, and those totals together make up $30, or $18, sorry. Based on how these equations are written, what method of solving might be the most efficient? Why are you saying elimination? Why do you think elimination? What is it about the equations that make you think elimination might be the most efficient?
Because we can find the opposites for.
Okay, we can find the opposites. What is it about the way the equations are formatted?
Whoa.
None of the variables are alone.
Okay, none of the variables are alone. That I would agree. That's part of it too.
It'll be like easier to like manipulate them to make one of them disappear.
Yeah, it might be easier to manipulate one of the equations to make one of the variables eliminate. If you notice, the variables here are already kind of like stacked on each other the way the equations are written. So maybe as you're looking at this, elimination might make the most sense. If I wanted to eliminate, does it matter which variable I eliminate? No, take a second and eliminate one of the variables so we can solve. Take just a second at your desk and try to eliminate one of the variables.
Nah, I can't do it.
Think about what eliminates, what kind of numbers eliminate.
Oh! You have to. Oh, I can't do that. That looks like a 30. Miss, can we change the variable?
If you want to change the O, you can. I know it looks like a 0.
30.
That's okay. You can use X and Y. Earlier today we used an O and it looked weird. What can I multiply one of these equations by to eliminate?
2.
What?
Negative.
If we multiply by -2, what variable are we trying to eliminate?
A.
The A. Okay. Now, one really important thing here. When we multiply this, it has to be everything being multiplied. So -2A minus 2O equals -14. So it's an O.
Negative 14.
Now, if we combine this,
So those are both.
2A eliminates.
Yeah.
3O and a -2O give you what?
But wait,
No.
2 negative
Oh.
nothing. 2 times.
Oh.
How do you get 1 O? Isn't it?
3, this is +3, and -2. Is that,
Wait, are you multiplying the top or the?
I already multiplied the bottom equation. I already rewrote it.
So how you get -2 out of 0?
We multiplied everything by -2.
Yeah, but isn't that O a 0?
No, it's an O.
It's a 1.
There's 1.
Oh,
So -2
I thought.
times
Oh,
1
I thought it
is
was. I'm stupid. See, that's why you don't.
Relax. And then if we combine
Wow,
18
not that
and
long.
-14, we have 4. So what does this tell us? O equals 4. What does that mean? Orange is equal. What is it about the orange that equals 4?
The pound.
Pounds. 4 pounds per orange, which means how many pounds are the apples?
3 pounds.
3. Yeah. Could I check with the cost as well?
Yeah.
I could, and you'll see in the next example that it's a great idea to do that. So now that's really a recap of where we were yesterday. We identified our unknowns, we figured out what we already know, and we organized it to write an equation. Now you're going to take a look here. We're going to go through this one. What differences, quiet down please, what differences do you see in this problem compared to where we began yesterday?
Mr. Shorter.
This one has a fraction of this.
Now we're dealing with some fractions and some decimals. The structure of this problem will not change. So as we go through this is a great example to have written down. You'll see that there's things we can do to try and make solving this problem a little bit easier for us. Now, as you go through a lot of these, it depends on your strengths. If you feel really good with decimals and fractions, then maybe you don't need to make adjustments as you go. If you feel that that's a weakness of yours and you're in the process of practicing it, there might be a couple of things that you can do to figure out how to make this problem work a little bit more for you. So here's what we know. Mr. Torres spent $30 to buy 9.5 pounds of ground beef and chicken for a family cookout. If the price of ground beef was $3.50 per pound and chicken was $3 per pound, how many pounds of each did he buy? Where do we begin here? What are we trying to find? What pounds? We're trying to find the pounds of each. All right, and what did he buy?
Ground beef and chicken.
He bought beef and he bought chicken. So what variables do we want to use?
C and B.
We can use C and B. That works. We can let B be the pounds of ground beef and C be the pounds of chicken. So now what? We found our unknowns. Now where do we go? What are we going to do next?
Take our values to make an equation.
Okay, what are we going to do? What are we going to use to create an equation? Do we really know? Have we identified what we have yet?
We can start now.
We can start now. Let's figure out what we know. Let's identify the information that's going to be helpful, because when we create a system, those two equations, right, we want to find themes, right, information. One of the equations, like in the previous example, one of the equations pertain to money, and one of the equations pertain to the pounds of fruit. So we want to figure out what it is we're really talking about in this problem. What information do we know? He spent a total of $30
On 9.5
on a total of 9.5 pounds of beef and chicken.
That's 9.5 pounds of honey.
per pound
Ground beef was $3.50 per pound.
and $3
Chicken was $3 per pound. So based on the information that we know, what do we think the equations will be about?
like
Those big ideas, like the big information pulled out of this problem.
how much he spent.
Okay, so one could be on the money spent. And what about the other equation?
The amount
Per
of pounds.
Yeah, the number of pounds would represent, based on the information we're given, we can most likely put together an equation about the cost, and we can put together an equation about the pound. So let's start with the weight. What kind of equation can we write, or what would the equation be regarding the weight of the food that Mr. Torres bought?
B plus C equals 9.5. B equals
What does that, can someone explain that in a sentence? What that means, that equation that we just came up with?
Beef and chicken equals 9.5 pounds.
What about the beef and chicken?
So what do you-
that equals the
it equals 9.5 pounds.
the weight
Their weight.
The weight of the beef, yeah. And the reason that I'm being picky about that
Yeah.
is because in the next equation we're going to be talking about the cost of the beef and the cost of the chicken, and that can trip some of us up. Some of us might accidentally say B plus C equals 30. Does that make sense?
No.
No, because the
Oh,
weight
put
of
the
the
pounds.
beef and the weight of the chicken wouldn't equal $30.
It would equal
Wait, put the pounds, miss, put the pounds.
So we could say the weight of the beef
Put the pounds.
and the weight of the chicken is
together.
9.5 pounds.
B for B, miss.
Do we want to bring in another variable?
No.
No.
Why?
We don't need it.
But you're gonna confuse it.
But maybe one day you can.
Well, here's the thing. Here's the thing. In the question itself, what are they asking us to find?
How many pounds?
They're asking us to
Oh.
find the pounds. So that means our unknown represents the pounds of beef. So our B actually represents the pounds of beef. And the C represents the pounds of chicken. So we don't actually need to identify that again, because we kind of already have. Okay, we've already identified the other information in the problem. How can I write an equation that represents the cost?
3.5 B plus 3 C.
Hold on, I'm sorry, say that One more time.
3.5B plus 3C equals 30.
What does that equation mean? Can someone explain that equation in a sentence? Patrick, go ahead.
Every pound of beef is $3.50. And add that,
Miss.
Keep going, Patrick.
and every 3 pounds of chicken, every pound of chicken is $3, and together they equal $30.
Okay. Okay, what else do we have to definitely mention there? It's not just that it's $3.50 per pound of beef and $3 per pound of chicken. What else do we factor in? You're right to give us the total. Per all of our pounds. Yeah, depending on how many pounds we buy, that'll change our cost. So we have our equation here, 3.5b plus 3c equals 30. If people make a mistake at this equation, what mistake do you think they're making? A lot of times, for those of you that might make mistakes here. What about this might get confusing? Especially if you're using an X and a Y.
You might forget which values were.
Yeah, sometimes you might see this happening. If I did this, what mistake did I make? If that was my equation. Yeah, sometimes that happens, especially when people use X and Y, is that we accidentally flip-flop the coefficient with the variable. So be really clear when you're going through that if this is the pounds of beef, that it really is $3.50 per pound of beef. So now we have our equations. We just created that second one. What method looks like it might be the most straightforward and efficient to use? Elimination looks pretty efficient. If I wanted to use substitution, what would I need to do? If I wanted to use substitution, what would I need to do?
Oh, you have
Say it one more time.
Oh,
What do you think?
have to get one variable by itself.
Yeah, I would have to get one of the variables alone. If you wanted to do that, and I know some of you feel really good with substitution, you can do that and isolate your variable. If I was going to eliminate, is there a variable that I could eliminate maybe a little bit easier than another one? Sorry, what do you
Yeah.
think?
The 3C.
Why? Why do you think eliminate? Now you could eliminate B if you wanted to, but why do you think eliminating C might be a little bit more straightforward, Jeremiah?
Because it's a whole number.
Because you're dealing with a whole number. If you were going to eliminate C, what would you multiply by? Which equation would you multiply, and what would you multiply it by?
3.
Multiply
The
by
bottom.
You can multiply the bottom equation by a -3, which you could do. If you wanted to eliminate the B, what would you have to multiply an equation by? Yeah, you'd be multiplying by a -3.5, which then can get a little dicey if you're multiplying -3.5 times 9.5.
It's -3,
You'd
right?
still get the same answer. Okay, take a second and let's multiply this out. Or if you're going to substitute, you can substitute. Choose your method. I'm trying to find the solution to that system. Which one should we eliminate?
The C.
Okay, let's eliminate the C. How am I going to do that?
Multiply by -3.
Multiply by -3. So what do we get for our equation?
-3B minus 3C equals -28.5.
Is there a way I can do that multiplication faster in my head? 3 times 9.5?
Oh my.
Any ideas for that? A little quicker in our head? Multiply 3 times 9.5. Can I do grouping of that multiplication problem?
Yes.
How?
X equals.
You can do 90 times 3. 90 times -3.
Why 90?
Because, oh wait, no, 9.
You could do 9 times 3, which is
-27.
9 times -3 would be -27. And then what else would you have to multiply?
0.5.
Times, which would be 1.5. So you would get the -28.5 that way. That's an option for those of you that struggle to multiply. You can group that. Multiplying negative 9 or 9.5 times negative 3 is the same thing as multiplying 9 times negative 3 and then adding it to 0.5 times a negative 3. And in your head, you can all multiply 9 times 3 and you could all multiply half times 3. So that's an option for you. Now, based on this calculation now, I rewrote this equation. What eliminates?
C.
The 3 C's eliminate because they are opposites. What do I have for my B's now?
0.5.
And what does it equal?
Negative 19.
One
Oh,
point
that's
five.
a third.
That.
Oh, that's a
B equals 3. Ha, miss, I got it.
Very
How was that funny? I don't get how that's funny.
If B is 3, what does that mean? What's B?
B is the bond.
Say it again.
Beef.
The beef. The beef is 3 what?
Pounds.
Pounds. If the beef is 3 pounds, how much is the chicken?
What?
6.5.
How do we know that?
Well,
Even with, I mean, yes, you are substituting, but what information do you know in the beginning?
That is 9.5 pounds.
Yeah, there were 9.5 pounds total.
Oh, so 6 point.
Now, the key here, the key to this solving, the key to this problem, and hopefully it helps you develop your own strategy, is that you're writing 2 related equations. They're not 2 exact equations. All the equations that we have created have been related, but they've been about different things. Right? The first equation that we did was for the weight of the chicken, specifically just the weight. And then the other equation had to do with the cost of the chicken. You won't always see one of the equations representing cost. When you get to your independent practice, one of the equations, one of the situations, the systems, doesn't involve cost. But you're still identifying what 2 big pieces of information can I write an equation about, and how can I solve from there. How would we prove that beef was in fact 3 pounds and chicken was 6.5?
wow.
That both of them were 9.5 pounds together.
So now, the first equation that we can check is this first equation that we created. And that's pretty much how we figured out once we got the B of 3. We were able to say, well, I knew it was 9.5 pounds total, so chicken would have to be 6.5. But what about the other equation? This equation here. Do we need to make sure that it would calculate? Might make sense, because what happened if I just did a tiny calculation error and I ended up with B equals 2? I can't just assume that if my pounds of beef, I came up with 2, that chicken must be 7.5, because that wouldn't have worked in this equation here. So when you're checking a real world system, or really a system of any type, it's not a bad idea to take the extra minute and substitute into both equations. If you did that and you calculated in here $3.50 for 3 pounds of beef, how much money would that be? $3.50 for 3 pounds. $10.50. And how about $3 for 6.5 pounds of beef? Chicken, sorry. Would be $19.50. Does that equal $30? Does that equal? Yeah, it does. So we know that it worked in this equation, it worked in this equation, so our answer would have to be the beef was 3 pounds and the chicken was 6.5 pounds. Yeah. This one or this one? No. That one. Yeah, so this actually, we started to touch on it yesterday, all about the creation of the equations. Typically, one of the most confusing things is for people to figure out what equations am I writing. If we try to focus on these 2 big ideas that we're going to pull information for, it might be a strategy that helps us. And the reason I say big ideas or big themes, I know in ELA you're always citing evidence and you're finding information to kind of like relate to something. And that's very similar. You good? Yeah. All right, you're gonna try one with the people that you're sitting with. here. We'll take like 6 minutes on this, maybe a little bit more. Let me pause the video and I'll explain exactly what we're gonna find.